Okay, so in this video, I'm going to go through the solutions of the AP Classroom homework assignment in preparation for a test coming up where review this could be. Let me just get these out of the way. Okay, so these were not too bad actually. In the very first question, we are given the position of a particle moving along a coordinate axis. So that is x of t is given already. Just be careful you write it down correctly. So we want to figure out when the particle is at rest. So that triggers me to think of define where velocity is going to equal 0. So the derivative of this would be 6t squared minus 42t plus 72. I'll factor out a 6, which is a GCF, and this is what's left, t squared minus 7t plus 12. I'll reverse FOIL that, as I call it, into t minus 4 and t minus 3. In t equals 4, t equals 3. So these will be the two times when the particle is at rest because velocity equals 0 there. In number 2, this is the position of a particle. It's just this expression, negative 5t squared. And we want to know what the average velocity is. So that's the change in position divided by the change in time. So the position at 3 means to put in 3 in for t, and that produces a negative 45, because 3 squared is 9 times minus 5 is negative 45. When I put the 0 in for t, negative 5 times 0 is 0. So then negative 45 minus 0 is negative 45, divided by 3 is negative 15. In number 3, it's a function within a function. So I'm going to take down this power, drop it down in front, and make it a 5. I'll repeat the very inside. I'll decrease this power by 1. And then I'll times it by the derivative of the inside, which is a quotient rule. So I'll rewrite the bottom function as x plus 1 times the derivative of the top, which is 1, minus the top, which is x, times the derivative of the bottom, which is 1, all over the bottom squared. These x's here will add to 0, and they will add to 0. And what's left here is a 1. Just looking here at the bottom, times the derivative of the top, which is 1, minus the top, which is x, times the derivative of the bottom. So what's left on top here is just should be careful here I clean that up, because it's x plus 1 minus x. And I think that's what looked a little confusing to me. So what's left over on top is a 1, and then I squared the bottom. And then x to the 4th power is x to the 4th power. And this x plus 1 to the 4th power is x plus 1 to the 4th power times that x plus 1 squared gives me x plus 1 to the 6th. Number 4 is a very common question that comes up on the exam. We want the derivative of this function within a function. So the derivative of the outside is f prime. I'll repeat the inside, which is ln, times the derivative of the inside, which is 1 over x. So now I need the derivative of f at ln of x. Well, this is f. I'll take its derivative, which is 2x plus 2, and I'm going to evaluate this derivative at ln of x. So replace the x with ln of x, and I'll get that expression. I'm just then going to copy this over to here for that, and it becomes 2 ln of x plus 2 times 1 over x, which came out to be that choice A. In 5, it's pretty easy. It's just the derivative of e. So I'll rewrite the function itself, which is here. And the derivative of that exponent is 2x to the negative first. Drop down the power, repeat the x, and decrease it by 1. And that's the derivative right there. In number 6, all we know is that the limit exists. So we know that the left-hand limit equals the right-hand limit, but that's not enough to guarantee continuity. A limit existing does not imply continuity, and it certainly does not imply differentiability. So we don't know for sure that any of those are true. In number 7, the function has to be continuous but not differentiable, and the only place that can happen is there either is a vertical tangent, where the segments get very vertical, or where there's a corner point, and that's happening at A, because the function is continuous at A, but not differentiable there. In here, we've seen this time and time again. This is your definition of derivative. So to invoke this limit, we got to recognize the function and the function is tangent of 3x at a equals x. The derivative is 3 secant squared 3x, and that came out to be choice B. And number 9, it's the chain rule. I'll drop down the 5, repeat the inside, decrease it by 1, and then times it by the derivative of the inside, and that looks like choice E. Number 10 is our inverse rule for derivatives. So I'm given a pile of information about f and f prime, and I know that g is the inverse of f, and vice versa. So I want g prime at 3. So my first step is to write out the rule. G prime at 3 equals 1 over f prime of g at 3. So then I need g at 3. And how I need to get that is I need g at 3. So I'm going to look to see when f has an output of 3, because the 3 here means a 3 there for f. So when does f assume that value of 3 is when x is 6. I'll cross out g at 3 as 6, and then f prime at 6 from the given is -2, and my answer is -1/2. In number 11, it's nothing more than a chain rule, a function within a function. So the derivative of the outside function is cosine. Repeat the inside, and the derivative of the inside is f prime of x squared times 2x. Replace x with 3, and I'll get cosine of f at 9 times f prime at 9 times 6. In number 12, I want g prime at 2. This is not an inverse rule of derivatives. Just because you see g and g prime, we don't know that g and f are inverses, so it's not that rule. So this is the function g given, and its derivative is the derivative of the outside, which is f prime. Repeat the inside and times it by the derivative of the inside. When x is 2, 2 squared is 4, minus 1 is 3, and 2 times 2 is 4. Now f prime at 3 has to come from this expression, because that is f prime. So I'll replace x with 3. 3 minus 2 is 1, cubed is 1, and 9, because 3 squared is 9, minus 4 is 5. 5 times 1 is 5 over 16. So this part is 5/16 times 4 is 5/4. And number 13 is just a good old product rule. X squared times cosine of 2x times 2 plus sine of 2x times 2x. Take out a 2x, and this is what's left. Again, factoring is the name of the game. In 14, again, it's the definition of derivative, but this time, this is my function. It's x approaching a constant. This is my function. This is its derivative. And the value I'm going to evaluate that at is e. That's what a equals. So the derivative is 20x to the 19th minus 3, and at e, it's 20e to the 19th minus 3. And last but not least is number 15. The position of a particle is this expression here. What's the acceleration when t equals 4? So the first derivative is velocity, 2t plus 4. The second derivative is acceleration, which is a constant 2. So a at 4 is just equal to 2. Okay, and that concludes the homework solutions to that AP classroom assignment.